well, I say that, but should know. We're talking about linear equations in two variables. Equation of a line, x, y. So y'all have done this before. It's nothing new. Using slope. Simplest mode for relating two variables is a linear equation, two variables, y equals mx plus b. The equation is called linear because it's a graph of a line. So we get this here. By letting x equal 0, you obtain the slope, b. So the line crosses the x-axis at y, or y-axis at y equals b. We have this here. We can have a positive slope, which means it's going up, or a negative slope, which means it's going down. Nothing new. But something that might be a little bit new is this here, m. Now, for the most part, I don't know why they use b for y-intercept. I don't know about you, but ever wondered why they use m for slope? Because for most things, it works out that they are very literal in what they do, especially for things they name in mathematics. Okay, we'll do that here in a little bit. But I learned this in college. One of the professors was wondering the same thing and told the students that he really didn't know, but it's actually kind of in the Latin, kind of Greek origins, in that for them, for slope or kind of increase or decrease, they have the word montaigne. It's kind of there for increase or lower in elevation, or kind of that slope, montaigne, m, kind of where we get it. It's also kind of where we get the word mountain, montaigne. Kind of those origins is why they use m. So some of the stuff that we have really comes from the Greek and Latin or Arabic, actually also orientation, because for kind of some of the stuff we'll do in here, algebra actually comes from the Arabic word aljabar, which means to complete, is where we get algebra, aljabar. So a lot of stuff Greek and Arabic, and sometimes Latin. But we have this here. Slope-intercept form. Nothing new. Slope increase decreases. We have this here. X equals a is a vertical line, straight up and down. Just if it's going to be at the x-intercept, is going to be the same value of a. It's just a line going straight up and down. The only thing that changes is the y value. The x value will be the same. Vertical line. I'm not going to worry too much about sketching the graph. Now these are two different versions of the equation of a line, because the first one is in our slope-intercept form, y equals mx plus b. Second one is still actually in that same form, y equals mx plus b. But for us, the second one, the slope is 0. It's a flat line. The first one, our slope is 2. Our y-intercept is 1. The second one, the y-intercept's 2. Flat line. So we have these here. And if we were to graph them, if we were going to go through that process, we need how many points to graph a line? 2. For the first one, we could use 0, 1, y-intercept. And from there, well, the slope is 2. So we could go up 2 over 1. So go from 0, 1, 3, 1. Or we could go down 2, left 1, from 0, 0, 0, 1. Left 1 would be negative 1, down 2 would be negative 1, 1. I'm going to get the graphing calculator out here in a minute. So really, we only need 2 out of these 3 points. Now the other one, y equals 2, well, we have 0, 2. We also have 1, 2. We're just moving left and right. The y value doesn't change. We actually have 7,864, comma 2. That one makes absolutely no sense. There's no reason to put that one, but y value doesn't change, x does. Another way we could graph a line is I could say 2x plus 1. 6. I was just doing that to fix the scale. I readjusted it the other day. So we have this here. Now I can go second table. Hey, 0, 1 like we said. We also have 1, 3, and negative 1, negative 1. I have my points. And if I absolutely had to graph from here, I could graph it. Or on the ACT, when you take that, because you'll take that pretty soon probably, if it asks for which graph, and it gives you several equations, start plugging them in. Figure out which one it is, because that'll help us there. We can also do the second equation, y equals 2. We have it. Yeah, I'd have to look back at it, but there is a way for the graphing calculators to do vertical x equal equations where we can get it to x equal, but I would have to look back at that because there's a certain set of keys you have to plug in for it to do those. And when it does those and set up to do those, I just turn it off. If you highlight this here, it would actually highlight y1 also. It would give us a third option because I don't think it gives us that for yours. So if we go over, and hit enter. No. So we'd have to turn that on. And I don't quite remember how to turn that on at the moment. I'd have to look back into that. So we have those there. Now this third equation is what we call standard form. AX plus BY equals C. We have it here. Now, standard form has a few key characteristics. One, X and Y are on the same side of the equal sign. Kind of as part of it. 1, A, B, and C are integers, positive or negative whole numbers. We don't have decimals or fractions. If we're getting it into standard form and we have decimals or fractions, we have to multiply through by a scalar a certain number to get rid of any decimal or fraction. Also, A is a whole number. Well, I'm going to rephrase that. A is actually a natural number. It means it has to be positive. And it's not, it could be 0, but no, most of the time, if we're writing it standard form, it's not going to be 0. Because if it is 0, we're actually more likely to write it as, well, it would end up being this. And A has to be 1, or not 1, but it can't be negative. A cannot be negative. If A is negative, we have to multiply through by negative to make it positive. Value of B, value of C. Those can be negative, but A cannot. Does that make sense? And this here is, I think, one of the easier ways to graph, because if we do have it and we want to plug it into the calculator, we have to get it back to y equals mx plus b form. Otherwise, the calculator is just going to have to fit. But if we do graph it and they give it in this form, I use sometimes what they call the cover-up method. And we can use AX, well, x plus y equals, okay, x plus y equals 2. This here, I'm going to get a box. Let's see, fill color black, line color black, awesome. Thank you. Because the 2 points that we're going to use are the 2 intercepts. And what I mean by the 2 intercepts, I mean the x-intercept and y-intercept. Because at the x-intercept, the value of y is 0. And at the y-intercept, the x value is 0. Because, again, with these inequalities, anything where I have to check a point, not an actual value, like with last week where we were solving equations and we're checking to see if it works, we're actually plugging in a value to check. One of the values I always like to check, especially with inequalities, is 0. 0 is a nice number. And the reason I say that is because if we're checking the y-intercept first, I plug in 0 for x. I, for the most part, put my hand on it, cover it up, because it is gone. And then solve from there. Well, what do I have left? Equals 2, yeah? So if x is 0, the value of y is 2. Okay. And then mentally, I kind of grab the box to find the x-intercept. Well, the value of y is, so in this case, x is, that's it. Then we have our 2 points. We can plot them and graph. If there was more to it, if we said had 2x plus y equals 2, I'm going to fill that in. Okay, well, I'm going to divide both sides. At this point, I'll just solve for x. We just have one thing we're just dividing. We don't have to actually add or subtract anything. So that's kind of the cover-up method, especially with graphing in standard form. Make one of them 0, solve for the other. Makes sense. Even with inequalities with lines, there are methods. Well, if it's greater than, we shade this side. If it's less than, we shade this side. I find it easier. I'm just going to take a point. Even in xy, the point I always use is 0, 0. Yeah, we can take that back. Put that away. Because even if this was an inequality, x plus y is greater than or equal to 2, well, 0, 0 is not a point on the equation, on the line, because if we graph and see, okay, that's not one of them, I just plug it in. 0 plus 0 is 0 greater than or equal to 2. So then I shade the side that doesn't have that point, and we're done. So 0, 0, 0 is a nice one to check points. So we have this equation. We graphed it. We saw those. Those are the 2 points we found. 0, 2, and 2, 0. And that's it. Not bad. Finding the slope. Given 2 points, y2 minus y1 over x2 minus x1 will give us the slope. And we have it here. y2 minus y1 is the change in y, or rise, how much it's going up. x2 minus x1 is change in x, which is our run. Now, another way to say both of these is delta y and delta x. Delta y is change in y. Delta x is the change in x. So really we can say slope is delta y over delta x. Change in y over change in x. So, rise of a run. We have this here where x is not equal to x2. All that's saying is that if we have 2 points, they don't make a straight line going up and down. It's not vertical. Because if it is vertical, the slope is undefined. There is no slope. Because if they're the same, it means the division. But the bottom of this fraction is we cannot divide by 0. So we have this here. Now, for the most part, the way we order them does not matter. Which one's y1, which one's y2, which one's x1, which one's x2. The thing that does matter with slope is that whatever y value we put first, its corresponding x value has to go first. So a lot of times when I set slope up, I will see the 2 points, and I'm just going to throw the y values in. Doesn't really matter which y values first, which one's second. But once I set those up, the x values have to mirror it. Does that make sense? Now, distance formula. This here, the only key part of this, y's go together, x's go together. Order doesn't matter. And the only reason order matters for slope and not distance is because of the square. because flipping the order of 1 will cause a sign change. So where it should have been negative, it's positive, or where it should have been positive, it will be negative. And as long as they match up on top and bottom, we're good. Here, that square, that sign change, or kind of that would cause by the last one where we flipped the values, had them in the wrong order, is corrected because of the square. So it takes care of that. The other one that doesn't order, making sure if we put the certain y value first, we need the x value first, midpoint. Because they're independent of each other, the actual sign is going to take care of because we are adding, not subtracting. So those are the two. Order really doesn't matter. But midpoint, whichever one goes first, the other one has to go first. And I feel like at this point we feel comfortable with slope. Because as you can see here, 7 minus 4 over 5 minus 3 gives us 3 halves. If we flip it, 4 minus 7 over 3 minus 5, we flip both, gives us negative 3 over negative 2. Yep, so the sign change that was caused by flipping it is offset. However, if we just flip one of them, if I said 7 minus 4 over 3 minus 5, well, 7 minus 4 is still 3, but 3 minus 5 is, which gives us negative 3 halves. We have that sign error. But in the distance formula with this being squared, would correct that, because it would make it 9 plus 4, positive 4, because of the square. Questions on this here? I don't think, I'm going to do the first one, but I don't think we need to go a whole lot into finding slope. And really, at this point, we can plug the whole thing into the calculator, let it do it for us, and be done. I mean, we could do the others. So I started out with doing 2 minus 2. Which number goes first? For x. Or 2 minus negative 1, because the two y values are both. Yeah, it doesn't matter for this one here. But even looking at this, what's the numerator going to be? 2 minus 2.
Oh, 2 minus 2, 0.
Well, if the numerator is 0, the whole thing's going to be 0. Yeah, so it is 3. 0 over 3 is 0. That's fine, because again, we can have a number divided by 0, or 0 divided by a number. We just can't have a number divided by 0. 0 can't be in the bottom. And we can do the last one. Four minus 1 on top, 3 minus 3 on bottom. 4 minus 1 is? 3 minus 3 is? So the slope is? Undefined. Yeah, I went on to the last one. Now, this is above and beyond. I'm going to show you here. Well, not so much, but it's a deeper explanation of this, because probably for the most part, what most teachers have told you, we can't divide it by 0. That's it. In the story, nothing going on from there. Now, this is there's a more intricate detail, because I'm not going to go into the full explanation on the Colcord Public Schools, my webpage attachment. There's a whole channel called Numberphile on YouTube. They have their own webpage. They go into tons of stuff, mathematics stuff. It's I find it really interesting. But they go into this explanation here. And really, they start off with saying just multiplication is a fancy version of addition. It's just a fancier group of addition. Division is just a fancy version of subtraction. Because if we wanted to say 20 divided by 5, well, we know 20 divided by 5 is 4. We could say 20 minus 5 is 15 minus 5 is 10 minus 5 is, and 5 minus 5 is. So we did this 4 times, so 5 goes into 20 4 times. So we can do the same thing here. 3 minus 0 is, do it again. Are we progressing anywhere? No. So this is part of the reason we say this doesn't work. It would be no solution. We can't divide by 0. For slope, it's undefined because it's going straight up and down. And I'm not going to get into the full explanation, but at this point, it's tempting to say it's infinite, but it's actually not infinite. I mean, it does go on forever doing the subtraction, but the division's not considered infinite. And there is a full explanation going into limits as it approaches 0, 1 over x, dividing by 1 or any number, kind of going in there. Writing equations in 2 variables. So we know slope, and we do have this equation here, y minus y1 equals m times x minus x1. Point slope. So if we have 2 points, or we have a point in the slope, we can use the point slope form to find the equation of a line. Now we do technically have a 2-point form. But if you look at this here, it's not really any different than point slope form. It's just instead of having the slope, we plug in the slope formula for it. So really, I wouldn't use the 2-point, the one in green, because it doesn't really do anything. Let's see a point. Find an equation of a line. So if we're given a point and the slope, we can plug the point in the slope. And then simplify down to y equals mx plus b, and we have the equation of the line. And that's it. Now, I'm going to stop here. So we'll finish this up tomorrow. We could finish